All right, welcome back. In this lesson, we're going to talk about Bohr energy level diagrams, and we're going to draw Bohr energy level diagrams for atoms. This is starting on page 24 of the Science 10 note package. The Bohr model of an atom states that electrons are arranged in energy levels around the nucleus. Bohr's energy level diagrams state that electrons are arranged as follows. There's only a certain number of electrons that can fit in each energy level. There are 2 that can fit in the first energy level, 8 that can fit in the second, and 8 that can fit in the third. You always have a note here that there's 18 that can fit in the fourth energy level. As you continue to grow atoms, then you will have even more electrons that can fit in their energy levels. Electrons on the outermost level are called valence electrons. That's an important vocabulary term here. We're going to call them valence electrons. That is the name we give to electrons on the outermost shell for an atom. The last digit of a group number is the number of valence electrons in the outer energy level. Put a little note here. This works for groups 1 to 2 and groups 13 to 18. What they're saying here, this last digit is the number of valence electrons. If you had, for example, group 14, that's carbon's group, then carbon has 4 valence electrons. The period number, so just to recall, this is my periodic table here. The group numbers are the numbers on the top, so hydrogen and the alkali metals are group 1. If we jump over here, carbon is group 14. It's got this column 14. Period numbers run down the side here. So hydrogen and helium are the only 2 elements in period 1. In period 2, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, and so on. One way to remember how many electrons can fit in each level of the Bohr energy level diagrams is asking yourself the question, how many elements exist in that period? Period 1, or energy level 1, has 2 elements, hydrogen and helium. So there's 2 electrons that can fit in that energy level. Energy level 2 has 8 elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. 8 elements in this row, and so it can hold 8 electrons in that shell. The period number is the number of energy levels that an atom has. If we take a look here, lithium, you can find lithium on the periodic table. Lithium is in group 1, first column, but it's in the second period. That's the second row of the periodic table. So we can say it's in group number 1, period 2. This means that lithium is going to have 2 energy levels. Lithium has the atomic number 3. The atomic number 3, so we know that lithium has 3 electrons total. However, if we start putting electrons into their energy levels, 2 of them can fit in that first energy level, and 1 fits in the next energy level. Valence electrons are the number of electrons in the outermost energy levels, so there's only 1 valence electron here. There's only 1 valence electron for lithium. If we take a look here at this atom, we can try and figure out some information about it. First question asks, what's the period number for this atom? In order to answer that question, you can ask yourself, how many energy levels are there? So what's the period number? How many energy levels are there? It's a bad Y for energy. There we go. We're taking a look here. It's got first energy level, second energy level, third energy level, fourth energy level. You've got 4 energy levels, which means that this atom would be in period 4. What group is this particular atom? Recall that the group number is related to the last number of the number of valence electrons. If you take a look here, we've got 1 valence electron, 2 valence electrons. That will help us figure out what group number this atom is. So how many valence electrons are there? This is related to the group number question. There are 2 valence electrons on the outside. This is a valence electron, and this one here is a valence electron. This would be in group 2. Another way that we could have gone about this is by looking at the nucleus. This Bohr diagram in the middle here shows the nucleus and what you would expect to find there. You'd expect to find 20 neutrons and 20 protons. Remember that the number of protons is the same as the atomic number. If we've got 20 protons, we know that our atomic number is 20. We could have gone to the periodic table and found atomic number 20, figured out that was calcium. We can see it's in period 4 and in group 2. So we could have answered the questions by going about it that way. But because we know that the atomic number is 20, we know that this is a calcium atom. Note here that calcium should have 20 electrons, so let's count them up to see if it does indeed have 20 electrons. We have 2 in the first level. If we go to the second level, we've got 1, 2, 3, 4, 5, 6, 7, 8. That brings our total up to 10. In the third level, we have 1, 2, 3, 4, 5, 6, 7, 8. That would bring our total up to 18. And then we have these 2 valence electrons, which means the total number of electrons in calcium is 20, which matches our atomic number. Take a look at these diagrams here and try and figure out for yourself. Pause the video now. See if you can figure out what element is being depicted in each of these diagrams. For these diagrams, the positive in the middle means a proton, the negative on the outside means an electron, and these zeros here are neutrons. So pause the video now and then try and work through this one. If you've paused the video and you've tried it out, then we're going to look through here. This one has 1 proton in the middle. It's got 1 electron on the outside. Therefore, its atomic number must be 1. And atomic number 1 is hydrogen. If you take a look at this next one, it's got 2 protons in the center. Those are neutrons, not protons. And it has 2 electrons, so it's got to have the atomic number 2, which is helium. And the next one, 3 protons, 3 electrons, I just wrote 2, 3 electrons, which means its atomic number is 3, and this is a Bohr diagram of a lithium atom. The next question asks us how many valence electrons are in an atom of each of the following elements. So if you're looking here, we're going to be using the group number, the last number of the group number for these. So if you look, first question asks about magnesium. Magnesium's in group 2, so we're going to say it has 2 valence electrons. And this trick with the valence electrons, I think I wrote it on the last page. This works for groups 1 to 2 and 13 to 18. It doesn't work very well for transition metals, but this trick will work as we jump over to tin. Tin is in group 14, so we're going to look at the last number of the group number, which is 4. And so that means that tin will have 4 valence electrons. Arsenic. If you're finding arsenic, arsenic's number 33. It's one of those metalloids. It's in purple on this periodic table. It's in group 15, so it would have 5 valence electrons. And you're welcome to keep working through the rest of these here as well. I'm going to jump to the next page here, where we're going to work on actually drawing these Bohr energy level diagrams. To draw a Bohr energy level diagram, you're going to use the periodic table to determine the number of protons, neutrons, and electrons of the atom. Place the protons and the neutrons in the nucleus. And the nucleus will just be a circle in the center. Remember that the number of protons is the atomic number. And remember that the number of neutrons is your atomic mass if you subtract the atomic number. And for atoms, the electrons will also be our atomic number. You're going to use the E- symbol to represent electrons, and you'll put electrons in according to energy levels. Remember that the first energy level can hold at most 2 electrons. The second can hold at most 8. The third can hold 8. This reference here as the octet rule, as 8 electrons. I think octopus in this one. And you should also know that the fourth energy level can hold 18. 18 electrons in the fourth level. So I'm going to just write here that the fourth level can have 18 electrons. This is the same thing here, that the first level should have 2. The second level can have a maximum of 8. Same with the third. And the fourth level can have a maximum of 18. We're not going to make you draw anything greater than calcium, so you're not going to actually see 18 electrons on the outside there. Here's an important note. You cannot place electrons in the next energy level until the previous energy level is filled up. So once you determine how many electrons you have in your atom, you're going to start by filling the lowest energy levels and then working your way up. Let's take a look at beryllium here. This is straight from your periodic table. The atomic number for beryllium is 4, which is going to tell us that it has 4 protons, and because it's an atom, it also has 4 electrons. The number of neutrons for beryllium, we're going to round our atomic mass to the nearest whole number, 9, and we'll subtract the atomic number to get us that we will have 5 neutrons. This here is going to be my Bohr diagram. I'm not going to draw full circles, and so to save space, I will just have, this will be my nucleus here. In my nucleus, I'm going to have 4 protons, and I'm going to have 5 neutrons. Now I have 4 electrons to place. This is my first energy level here. My first energy level can hold 2 electrons, and I've got 2 left to put in my second energy level. I'm just going to put a label here that these are energy levels. Energy levels. And this will be my first, this is my second, and this is my third energy level. I don't put any electrons in the third energy level for beryllium because I haven't filled up the second yet. This also makes sense because if you look at your periodic table, beryllium is in the second period, so it should only have 2 energy levels anyways. Go ahead and pause the video now and try and make the Bohr energy level diagrams for sodium and chlorine. If you've tried making those, you can check your answers against mine. Sodium's got 11 protons, that's the atomic number. It's got 11 electrons. And then for our neutrons, we will take our atomic mass, round it to the nearest whole number, subtract our atomic number, and that will bring us to 12 neutrons. So I'm going to put 12 neutrons in the nucleus along with 11 protons. I've got 11 electrons to place. I'll start at the bottom energy level where I can put 2 electrons. Now I have 9 left to place. I can put 8 of those in the second energy level, and I'm left with 1 electron that can go in the third energy level. So you got to fill the bottom energy level first. We go over to chlorine. Chlorine's atomic number is 17. It's got 17 protons, 17 electrons, and then 35.45 will round down to 35. We'll subtract 17 protons, and so we'll get 18 neutrons. The neutrons and the protons go in the nucleus, which is this circle on the bottom. And then we'll put electrons into their energy levels. I have 17 electrons to place, so I'm going to put 2 in the first energy level. That leaves me with 15 to place. I can fit 8 in the second energy level. I'm left with 7 to go in my third energy level. Both sodium and chlorine are in the third period, so it makes sense that sodium and chlorine have electrons in their third energy level because the third period is the third energy level. Here's a periodic table. We skip over from groups 2 to 13, so we skip over the transition metals. They're not present in the first 3 periods anyways, but you can draw in Bohr diagrams for these. So for example, if you were going to do oxygen, which is in group 16 and period 2, then your oxygen Bohr diagram, you would draw a circle for our nucleus. Oxygen's got 8 protons. I'm going to zoom in on this just to make it a little bit closer. Oxygen's got 8 protons, and it's going to have 8 neutrons. You can show your calculation for that by doing 16, which is your atomic mass, minus 8, which is your atomic number, to give yourself 8 neutrons. Then I'm not going to bother drawing 3 energy levels because I know I'm only going to have 2 because oxygen is in the second period. But I've got 8 electrons to place. I will put 2 electrons in the first energy level, which gives me 6 left over in the second. These 6 electrons, remember, are my valence electrons. They're in my outermost orbital, or outermost energy level. And so this makes sense as well because oxygen is in group 16 and the last number of that is 6. I'm going to just put a label on these right here just to remind us that the top electrons are our valence electrons. So if you were asked the question, how many valence electrons does a sodium atom have? It has 1 in the outmost energy level. And how many valence electrons does a chlorine atom have? It has 7. That's all for today. There's a lot of good practice in the book for sketching Bohr diagrams of various different atoms. And next lesson, we're going to look at sketching Bohr diagrams for ions and what is meant by an ion.